Okay, so we're moving on today to lesson 8.4. Pause the video and take a look at the problem of the day. All right, so 8.4, the lesson's called Multiply and Divide Rational Expressions. This is a topic that you actually learned in Algebra 1, so hopefully you remembered a little bit once I actually cover the topic. But today we're going to take a look at, we split 8.4 into two parts. We're going to look at, I know it says multiply and divide. We're going to look at multiply only, but what we're going to add is simplifying as well, because that's the basis to it before we get to the more complicated ones. So start with the property. The property says, well, in simplifying rational expressions, if A, B, and C are numbers or expressions, what you're allowed to do, now remember there's A times C, B times C. If you are multiplying only, you're allowed to cross out like terms. So what that will leave me with is A over B. So let's take a look at an example or two here. You actually did that a long time ago with simplifying fractions, even though you probably didn't realize it. But let's see what we could split 15 into. 15 is what? 5 times 3. Think to yourself, what times what gives me 65? It's 5 times 13. Now with that being said, do you see how it's 5 times 3, 5 times 13? When you do multiplication, you're able to cancel out the same thing top and bottom. So that's how we would get the simplified fraction of 3 over 13. So that was something you learned a really long time ago in math. How we apply it to algebra, what you saw last year as well. Now this one's already factored for us. We're going to bring factoring back in this lesson, but it's 4 times the quantity x plus 3 and x minus 5 times the quantity of x plus 3. You can cross out x plus 3 from both of them. So our answer will simplify to 4 over x minus 5. Now be careful, because a really common mistake I see, let me just write something up here. Say I gave you x minus 2 over x plus 5. You are not allowed to cross these out, all right? And that's a very common mistake I see, and the reason being, you see how the sign in between here is minus and a plus? The only way you are ever allowed to cancel them out is if it's multiplication. So watch, times, 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 times. You cannot cross that out. That does not work. You can't tell me the answer is negative 2/5. That is wrong. All right. Let's look at our steps now. So how we simplify. Using the property, both numerator and denominator must be factored. You have to factor it before you could cancel anything out. That's what I was saying. You can't cancel out the variables as is. 1, factor completely, numerator and denominator. 2, look at factor denominator to see if x values are excluded. This is something we talked a lot about in the beginning of chapter 8. We're going to bring that into this lesson. And then 3, cross out common factors. Make sure all multiplication. All right. So let's look at example 1. Example 1, simplify x squared minus 8x plus 16 over x squared plus 2x minus 24. So in this chapter, we bring factoring back. I mean, I think you know this by now. We've seen it a couple times throughout the year, other than chapter 4. All right. So I have an x squared. That means I put an x in each parenthesis. Plus means signs are the same. They're both negative. And then I want 4. 4 times 4 gives me 16. Negative 4 minus 4 gives me negative 8. Now remember, now these are multiplied. I'm not allowed to, just to refresh your memory, I cannot cross x squared out. That is wrong. Why? Because of the minus, plus, plus, minus. The only time I could finally cancel things out is through multiplication. All right, so let's factor the denominator now. Once again, the same thing. X squared means I put an x in each parenthesis. Signs are different. Think what times what gives me 24? Then when I subtract, I get 2. We want plus 6 minus 4. 6 times 4 is 24. 6 minus 4 is 2. Now before we cross things out and get a final answer, do you see what's in the denominator? If you remember anything from the last couple lessons in chapter 8, we said that the denominator can never equal 0. So if I set these each equal to 0, I'm going to write my restriction all the way over here. X cannot equal what? can't equal -6 because I set that equal to 0. And it can't equal +4. I set that would equal to 0. So in step 2, we're looking at the x values that are excluded. I can't have -6 and 4. If I plug them back into the original, I'm going to get 0 in the denominator. Now the last part here, we're going to cross out what's the same top and bottom. Cross out 1x minus 4 up top and 1 in the bottom. So my final answer is x minus 4 over x plus 6. Now these examples, I'm going to have you talk about the exclusions, but you don't have to worry about it in the homework. All right, let's look at example 2. Simplify 40x plus 20 over 10x plus 30. This one, I could factor out a monomial. Now make sure it's the greatest number between them. If I look at 40x plus 20, the highest number I could take out is a 20. So I'm left with 2x plus 1. The bottom, I could factor out a 10. Then I'm left with x plus 3. Now once again, before we simplify, let's look at our exclusions. What numbers the denominator can equal, and I'll put them over here again. If I set the denominator equal to 0, 10 will go away, because if it's equal to 0, 0 divided by 10 is 0. But I could set x plus 3 equal to 0, which would give me x cannot equal -3. All right, so now we're allowed to cancel everything out. The parentheses you could see can't cancel because they're not the same exact thing. But we could take 20 divided by 10, which is 2. So I could write 2, 2x plus 1, over x plus 3. And that's my answer. You could multiply it out if you want. You don't have to, though. So 2 times 2x plus 1 over x plus 3. Now, we talked about simplifying. The next part, we're adding one step. We're going to multiply rational expressions. Multiplication is just one extra step where you combine the two fractions into one. So let's look at the rules here. 1, make sure all numerators and denominators are factored. All right, you can't cross out things if there's a plus or minus sign between them. 2, multiply numerators, which means write all expressions together. Don't actually multiply expressions. All right, if you multiply them out, you're going to get a huge polynomial. 3, same thing, multiply denominators. Just writing them all together. Don't actually multiply expressions. And then 4, divide out common factors. Now, for this first example, do you see how really it's 8 times x cubed times y over 2 times x times y squared? You see when I multiply, there's a whole bunch of multiplication symbols in between them. Instead of me saying don't multiply them together, you can actually do it for this one because you're not factoring. These steps more pretty much apply for the next one here. So let's go across. If we remember exponent rules, well, first of all, we take 8 times 7, the regular numbers. 8 times 7 is 56. Let's simplify the fraction into a numerator or a denominator. Now, if you remember with exponent rules, if I am multiplying, I actually add exponents. So 3 plus 4 is 7. Then if I look at y, don't forget y is the 1 here. 1 plus 3 is y to the 4th. Over 2 times 4 is 8. There's only one x, and then y cubed. Now, multiplication is, like I said, is only one extra step from simplifying. You make your fraction to one big fraction. From here, 56 divided by 8 is 7. Now think to yourself, exponent rules, if I divide, what do I do with them? I subtract them. So x to the 7th divided by x to the 1st, 7 minus 1 is 6. And then y, 4 minus 3 is 1, which is y. That's our answer. Now there is actually a shortcut to these. The shortcut is you could cross cancel if you want. Like I said, you could cross cancel to simplify, but I find over time that's a really hard method for some people. I think it's easier just to combine it into one to solve. Now, where we're really following the steps, where it says don't actually multiply expressions, because I know it could be confusing with this example here, is in problems like these. So let's take a look. Now in letter A, they actually already did this. Step 1, make sure all numerators and denominators are factored. So they did step 1 for you. All right. If we go back again, step 2 is multiply numerators, which just means you write them all together. You actually don't multiply, like for instance, you would have to FOIL these two or distribute. All that means is it becomes one fraction. So hopefully you're okay with this. Instead of me rewriting it, I like to do is just draw a new line. This is one big fraction now. After that, we could cross out what's the same. So here's an x minus 1. Here's an x plus 5. You could actually also get rid of this x here. Now you might be wondering why. Really, this is all multiplication. So you are allowed to do that. And let's see what's left over. In the numerator, you have 3 times 5, which is 15. In the denominator, we have 4 times x minus 3. And that's it. Now, if you want to, you could distribute the 4. Why waste your time to do that? This answer is acceptable. All right, so let's look at 4b. 4b, my first fraction is just x plus 2 in the numerator. I can't factor that or simplify that any further, so I'm just going to rewrite it. Now let's look at the denominator. The denominator is x squared minus 4. That's a difference of 2 squares, so you have x plus 2 and x minus 2. Now we're going to multiply that by the top. Now this piece here, if there's no fraction, it's just always over 1. Now x squared plus 2, I actually can't simplify for 2 reasons. It's not a difference of 2 squares. Difference means subtraction, like this one. And also 2 is not a perfect square. So that's as far as I can go. For the last part, we want to combine them into one big fraction. So instead of me rewriting it, I just like to draw the line back over. Now cross out what's alike, which are these two. So my final answer is x squared plus 2 over x minus 2. Remember, this is your final answer. You can't actually simplify it further. All right, I get a lot of people that would like to tell me, oh, this is x minus 1. That doesn't work. Remember, because it's not multiplication, there's a plus and minus sign between them. All right, let's look at the next one. The first one we could factor out of 3x, monomial. So sometimes it'll be monomial, sometimes it'll be factoring. X minus 1 is left over. And if it's all right, I'm just going to make this one a big fraction. We'll look at each piece individually. Up here, if I factor, I get what? X plus 5 over x minus 4. That's the top right. And the bottom left, I get x plus 5, x minus 1. And then I can't do anything with the 3x, so I just bring it over in the bottom right. So let's start crossing everything out. The x minus 1 goes away, x plus 5. Even the 3 and x go away. All I'm left with for my final answer is x minus 4. That's it. So all that simplifies just x minus 4. All right, that's it for the lesson today. Work on the problem of the day and then complete the 2 problems, problems 4 and 10, in assignment 6 for tomorrow.